Hello, let's have a look at this question. A rectangle has 2 points, x and y, on the x-axis and the other 2 points, y and z, on the graph of this function, y equals something. As shown in the diagram below, the coordinates of z are, and they're given there, a and b, where a and b are positive numbers. Okay, so here's our problem, and as you can see, we've got some enclosed rectangle there, shaded region. Our job is, let's find the area of this rectangle. And really, best way of looking for area of a rectangle is by area equals length times width. So, we've got a length of 2a. Okay, because there's an a in the x direction that way, and there's an a in the x direction that way. So, altogether, 2a. And we've got a width given by the y coordinate. Okay, now the y coordinate here given there is b. However, in terms of a, we're going to draw on the rule. Okay, this rule here for to get the y coordinate. So when x is equal to a, we'll have our 9 minus 3a squared, and expanding that out, and we're going to get our area. Okay, now the next bit, it says find the maximum value of a and the value of a for which this occurs. So your maximum value of a, it's when, if you've got some function, okay, some here, this is an expression, some function that gives you the maximum, that gives you the area, and in terms of a, then the maximum of that function is given by when the derivative is equal to 0. That's always the condition for maximum values of something, when the derivative is equal to 0. So we'll make the derivative is equal to 0. There's our derivative, 18 minus 18a squared is equal to 0. Now we go ahead and solve for a, and we get a is equal to 1. Now, because it's the square, a squared is equal to 1, and we take the square root, that'll give you a equals positive or negative 1. If you look at the information at the start, here where it says, way up here, there it is, positive a and b are positive real numbers. That means a has to be greater than 1. Alright, so it's important to draw on that condition. The last part is, there's our value of a for which this occurs. Now we have to get the maximum value of the area. So we sub a equals 1 into the expression for area, and we get 12 units squared. Okay, I hope that helps.